Hello, welcome to part 3 of the passive solar energy presentation. We're going to discuss passive solar energy and sustainability. From a sustainability standpoint, passive solar energy systems have a high degree of attractiveness due to the following factors: great potential to reduce energy usage, more environmentally friendly as they utilize natural elements to heat and cool buildings, and can promote better health standards in buildings compared to conventional systems. So let's touch on the current state of energy usage in buildings. In developed countries, the building sector consumes roughly around 30% of final energy. This varies depending on location, where heating or cooling days can be quite high. This may be as much as 50% of energy being used to heat or cool a building alone. In temperate climates, depending on local variations, design, and occupational patterns, roughly half of total energy use for a typical building is used for indoor air conditioning. Improved energy efficiency in buildings seems to be a universal goal, either directly due to rising fuel energy costs or increased regulation to meet climate change mitigation goals. For example, many developed countries, such as Canada, are mandating a certain percentage of homes adhere to net zero building requirements in the coming years, which will require homes to drastically cut their energy consumption to meet these net zero goals. The second part of sustainability in regards to passive solar energy is the environmental implications of reducing greenhouse gas emissions of building energy requirements from building structures through energy efficiencies by utilizing natural processes to heat, cool, and light a building are very strong sustainability alternatives compared to more wasteful conventional climate control methods. Passive solar systems can heat and cool buildings by eliminating or reducing dependency on conventional HVAC systems. Passive homes greatly reduce their emissions by downsizing to much smaller heating and cooling units that can even use as little energy as a hairdryer to heat or cool a structure. Passive solar systems do rely on higher R values in their insulation and require thermal mass to store heat or cold, but this is also an opportunity to use renewable forms of building materials such as biomass and such as biomass derived substances like biochar that can be readily incorporated into building materials, which is a way to sequester carbon into building structures and allows for decomposing of building materials that has little to no impact on the environment. And the third aspect of sustainability with passive solar energy is the social aspects. Um, Social aspects of sustainability relating to passive solar buildings are they can improve overall health for the building occupants using natural ventilation to maintain higher quality air standards. To maintain higher air quality standards. Rely on the sun for natural lighting that improve the indoor environment in buildings. And according to researchers involved with sustainable design, the design of buildings must move toward the construction of houses that generate positive impacts at both environmental and societal levels. Buildings designed with the criterion of regenerative sustainability consider, in addition to energy efficiency and the use of renewable and/or alternative energies, the improvement of the health and well-being of users. Among these buildings are houses with large glazed surfaces that allow integration with the environment and an improvement in health due to the provision of natural light. In closing, I would like to highlight the important points that have been discussed. We began with a look at the phenomena concerning air movement and an understanding of how passive solar energy is defined, and we looked at the science of heat transfer theory, including the elements of conduction, convection, and radiation, along with an analysis of this phenomena concerning how air moves in buildings was touched on as a way to better understand how natural elements are utilized in passive solar systems in buildings to heat and cool them. We covered basic passive solar systems of direct, indirect, and isolated gain. The strategy of building orientation was highlighted as a fundamental, simple, and cost-effective way to improve building energy efficiency. The idea of building orientation was used to better understand how computer modeling is a pragmatic approach for designing passive solar buildings and can be used as a tool for transitioning passive solar concepts to the residential and commercial building sectors. And lastly, we cover the aspects of energy usage of buildings, environmental implications, and social aspects of passive solar energy as it relates to the concepts of sustainability. Thank you, and I hope you enjoy the presentation.